All right. How's it going, everybody? So I'm with Lacework. We're kind of sponsoring the event, but my talk is a little bit more about cloud security. It's more of an intro thing, so I hope a lot of you are very familiar with the topics I'm going to talk about. But the idea is we'll actually go through, we'll skip that, and talk about the agenda. I used to be a consultant, so I always do agenda slides. It's kind of a sad thing, but hopefully it gets us all on the same page. We'll start with an introduction, who I am, so you maybe understand why you're listening to me. The next thing we're going to talk about is the anatomy of a compromise. This is a compromise that happened a couple years ago, but it's pretty common, this type of thing that happens. Then we're going to talk about, okay, compromises happen. What sort of things should you look at to secure? Then we're going to talk a little bit about how Lacework can help, and then we're going to do a product demo. If any of you were here yesterday, Ernest was the company, and Odie was the guy who did a talk. He did mention Lacework. They're one of our active customers, and we have a whole bunch of other customers who would all be happy to talk to you if you had any questions, thoughts, or concerns. So without further ado, we'll get started. I'm Chris. I was Lacework's first systems engineer. I have been in this field for a while now. I got my MCSE on NT4, so if any of you are tracking, I got it in '99. Windows 2000 came out shortly afterwards, so I felt like that was a big waste of my life, but it's what really got me started in IT and security. From there, I've had a series of jobs. I started out in a SaaS company before SaaS was cool. It's actually interesting. It was like an endpoint agent tool, and it really got me into the world of what agents can do from a visibility and a data perspective. Little did I know it'd be relevant many, many years later when I joined Lacework, but it was. I've also worked for Colos, if anyone's familiar with Rackspace. I didn't work for them, but I worked for their competitor. And then I worked as a consultant for a couple of years, helping people like you understand what they're doing with AWS, understanding how to secure it, how to move to the cloud, everything around those. At some point, I got my AWS Solutions Architect Professional Cert. So if you have any certification questions, I'm happy to talk to you either about the process, the approach, how to train your teams. I've had several of my employees get those certifications, so I'm happy to talk after about any of these questions if you have it. In all honesty, it's actually expired now. It takes 2 years to expire. It just expired in December. I haven't updated it yet, but I'm thinking about it. So moving forward, that's me. I want to talk a little bit about the anatomy of a compromise. Now, when we talk compromises, there's a lot of ways these can happen. But it all really boils down to, for at least the majority, one of four things. The first compromise is probably what we hear the most. This is a credential compromise. This is someone's lost their keys somehow, their username or password, maybe they've checked in their Amazon key, something like that, and it's out in the wild. We're all familiar with this. I would bet everyone in this room has been a victim of this in some way, shape, or form with all of the all the password databases. If you've ever logged into a website, your credentials were probably compromised once or twice. The next one is failure to patch known security flaws. Now this one can be very big, and this is often just somebody not getting to patches, or there's something that's breaking and maybe your dev team is a little slow at fixing the bugs. So you have these edge servers that aren't patched and someone's able to use a known CVE and get in. You can actually see a perfect example of this if anyone spins up an Ubuntu 14 server, type apt-get install Redis, and then open that up to the internet, and you will be hacked within a day. You'll probably be hacked several times within a day. But there's an open CVE, it's default on Ubuntu 14. This is how serious it is. So you have to be very careful about your configurations and your misconfigurations. I have a cool shirt too, not as cool as the last guy's. The next thing is insider threats. Now, insider threats are scary because there's not really a lot you could do about this, right? This is somebody within your company who decides for whatever reason They want to take your data and run or sell it or something like this. I think the most recent time was with Uber and Waymo, if anyone's heard about that. But I don't really want to talk about that because there's not a lot that anyone can do. But we do have some behavioral-based stuff that might help you there. And then finally, human error or negligence. This is probably, in my opinion, the most common thing and the easiest thing for us as security professionals to guard against. Now, you're guarding against human error and negligence. This is where rules and configurations and things like the CIS benchmark come into place. And I'll talk a little bit more about that later. But the idea is somebody fat fingers something, somebody leaves open a bucket, somebody's trying to do something, and in a troubleshooting effort, they're like, I'm just going to open this to the world. And when I open this to the world, it allows anyone in, and that's not always their first thought. Their thought is, I just need to get this working, then I'll come back and secure it. So these are the top 4 things. I think this comprises something like 90% of all breaches and compromises. Everything else is like advanced persistent threats. So talking through that first one, how are credentials compromised? One of the more common ways recently, and this is one of the most impactful ones to everyone here, is something like GitHub. Who here has used GitHub or something like GitHub? If you haven't, I'm sure at least 2 or 3 people in your company, probably everyone on the engineering team does. GitHub is great. This is a place where teams can check in code. It's where you can have different revisions and merge them all together. This is how software is developed today. GitHub, anything like it. But what happens is people develop their code for a local environment or a walled off environment. And so they're doing a lot of maybe insecure hacks, like they're hard coding passwords or they're hard coding their credentials in because they just want things to work. And your developers really, like our goal as a security professional is to enable them to work. So we generally kind of look the other way when they do this. And we expect them to follow secure coding practices. And if they do this for their initial trial, they're going to go back and fix it. Well, that doesn't always happen. So what will happen is they'll type in from their local environment, they'll be like, oh, coding, finally it works, I'm gonna check in my code. And when they do, they'll do a git push, and this goes to the public. Now, most of the time, I would assume with any corporate GitHub, this is locked down, so it's not on the internet. Now, this is where that insider threat becomes an issue, because they could check it in, and then anybody at your company sees this username and password, now they can go imitate this person. But where this becomes a problem is if they accidentally check it into the wrong repository, or maybe they're working on a public repository. And that's where things start to happen. So to kind of check this isn't just me. Go on to GitHub, type a search for your access key ID, you'll find a lot of results. Now, a human's not gonna go through 258,000 results, but there's a lot of bots that will do that. And anything that matches appropriately, you can better believe that they're going to be trying those out and trying to access your account. And GitHub's only one place. These are all over the internet. So you should be very careful of your code. There's a lot of tools that are not Lacework that will help you with that. But it's very important. This is the walking through of people have gotten a lot better, but mistakes still happen. So what I want to talk about is a little story about a company named Cuber. At this company, there was a DevOps engineer who accidentally committed credentials to GitHub, much like I was talking about. And this GitHub was a public repo. And I see some of you laughing, so maybe some of you have heard of this story before. And as you know, once something's on the internet, it's on the internet. It's gonna immediately, even if it's only up there 5 minutes, there's gonna be a scraper, there's gonna be a duplicate. You might as well like scorched earth your environment because you're compromised. And so this company didn't realize that this happened. And they had a hacker able to access their environment. And they were in there for a long time. I forget how many days, but it was over a month. And they had full access and they exfiltrated 50 million customer data records. And then The only reason Uber found out was because there was a ransomware demand. The idea was, you pay us, we won't tell anyone, we'll delete the data. Now, I don't know if I'm gonna trust someone who's hacking me to do the right thing, but they went ahead and did. And so they paid $100,000 to this malicious actor to cover it up. So right there, cost of a compromise floor, $100,000. Now this is 50 million customer records, but what ended up happening was even though they paid cover-up money, the incident still became public. And the US government decided that what had happened, this hack, was not something they wanted, it was not something they expected, and there's security controls that you should have in place, like a reasonable level of security to ensure that this doesn't happen. And they found that Cuber was liable to the tune of $148 million for allowing this data to be public. Now, how many people here work at a company where $148 million loss and they're gonna keep their job? Is the company still gonna be around, you know? Like, it doesn't happen too often. Like, this is a big deal. And the sad thing is, it could have been prevented with some very, very simple tools. You guys saw guard duty with SageMaker, but you inherently have problems when you're trying to manage enterprise scale when you're using point solutions. Point solutions are really great for a single account, but you eventually hit a scale problem where how are you going to deal with 50 accounts, or how are you going to deal with 100 accounts? And this is why guard duty was invented. This is why machine learning was not necessarily invented, but why it's used for this case. Because as an individual, it's really hard to understand and operate at scale past the 1 or 2 accounts. How many people here have more than 3 AWS accounts in their environment?
Nobody want to tell the truth.
Yeah. I know we have more, and we're a company of 60 people. So it's probably pretty common. Everyone who didn't have their hands up maybe doesn't know, but it's probably a lot. And if you have less, it's great because you have a very small account, but your blast radius is incredibly high. If somebody hacks that one account, your entire company could be at risk. So to kind of talk through some of these security events, just data leaks. This is just misconfigurations, people can access your data. This happens pretty much every day. We're a security company, so we watch some of these, but you could do this all day. You could find companies who've lost data. Anyone here hasn't seen it, you just aren't looking. The other thing is hijacked resources and compromised AWS accounts. Uber data breach cover up, 2 firings. I wonder what that was. This is the one that scares me the most. It scares me because I come from a small company, and in our small company, if something were to happen major, it could cause us not to be able to operate. And if you haven't read about this, I would definitely go take a look at Codespaces. So what happened with Codespaces is they got hacked, someone left keys out, and they received a ransom demand. And the IT team decided that they were gonna try and take back their AWS account. This is something I think any of us would think we'd rather do than pay a ransom. But what they didn't do, and they should have done, is contact Amazon first and say, we just received a ransom demand. We believe someone has access to our environment that shouldn't, and we need to make sure that we're safe. But they didn't do that. This was also one of the earlier companies. And when they went into their environment to try and lock out this other guy, he had got in there deeply enough that he started deleting everything. And then it became like a movie style race to try and like retain their data. And they ended up losing everything but like one database and a backup server. And it caused a company that was fully functioning and like maybe they were gonna make it into having to shut their doors overnight. And that's pretty scary. It's especially scary for the smaller companies where if you have a lot of IT, if you're a cloud first company, like you can do something wrong and you could lose everything. So pretty big deal. I'd recommend reading about it. It's kind of the thing that, to me, was the scariest thing I've seen. Then crypto mining, this was really great for us because it's just a cost that Amazon often forgives if you get hacked, as opposed to before where it's data and ransomware and you have to worry about it. And this is where someone would steal your resources and mine things. It's huge. That Redis server I was talking about, that's what the hack does. Happens with Elasticsearch, it happens with most things, and this is because it's very easy to automate with bots. I've actually put together a script that I can share with anyone if they want to practice mining Bitcoin. It's not really that interesting, but I'll help you out with it. But that's one of the more common things now because it leaves almost no paper trail. If you've looked too much, or a little bit into cryptocurrency, there's a lot of currencies out there that it's very hard to figure out who, what, when, where. And so that's why it's happening. So after I say all of this, you think, well, doesn't Amazon provide security? We've been here for a couple days and there will be a couple more to talk through it. And Amazon does. They provide really great security. Amazon has more people at their company working on security than probably any 3 or 4 of our companies put together. But Amazon's primary concern is their data centers. It's their data. And they provide everything they can for you, but it's up to a line, and then it's responsible for you to do the rest. It's like if anyone's ever rented a car, they provide you a safe, comfortable car that you could drive, but if you leave your keys in it, somebody can take it very easily. Just because you leave your keys in it doesn't mean somebody will take it, and that's what Amazon does. You're responsible for all of the services you spin up, you're responsible for all of your APIs, for basically locking the door and ensuring that nobody gets a copy of your keys. And if you leave the valuables in there, you don't want it to be easy enough that someone could just walk through, break the glass, and take it out. And this is one of the major problems we see. All those other companies, they just accidentally left their valuables out invisible. So it's really, really up to us to make sure that not only do we know what we have, we know what we shouldn't have, and to make sure that there's at least a base level of security for that. So to kind of summarize the reasons why some of these hacks happen that we talked about, it's because there's really a lack of visibility. There's a lack of visibility into what your servers are doing. There's a lack of understanding and automation for detecting these threats, and security must also be run at the speed of the cloud. Now, to kind of break these down a little bit, if you operate in a data center, your entry points and your exit points are very small. You've got firewalls everywhere. You've probably got a NAT for all your outbound traffic, and Palo Alto's probably sold you $3 million in security. And everything's done with firewalls, and you have groups of people who operate your systems. You've got a team who does your storage arrays. You've got a team who does your networking. You may even have a different team for your firewalls. You have someone in there who's doing the rack and stacking. You've got your VMware guy. You've got all of this. But once you move to the cloud, you've got one guy, and he can do all of those things. And so one of the things that we're all challenged with is playing catch up, right? Because before, I didn't have to know about spinning up a VMware image because I had a whole team who did that, or at least a guy. I didn't have to understand the implications of opening a firewall port because I had a guy who did that. I didn't have to worry about like my firewall and advanced firewalls and all of this. And most importantly, I didn't have to worry about my east-west traffic because it was inside the perimeter. And that's really where the cloud changes things. It changes things because somebody can get into your network in many ways, as simple as someone accidentally checking in credentials to GitHub, or maybe you have a server that, you know, just some developer was doing a test. Maybe they wanted to try a honeypot with Redis. They put that server on the internet and it gets hacked, but what they didn't realize is the role they had attached to that server was too permissive, and someone was able to use that to create credentials. Like, there's a lot of ways now to get into your cloud environment. It's like really, really scary. And so you could see we're in a very overfunded security market, and this is because there's 1,000 ways to secure things. But at the end of the day, what you really need is security, visibility, and the ability to understand everything at scale. And so there's a lot of tools out there. We're one of them. We like to think we're the best. That's why we're here, right? But it's something that we provide sort of a blueprint. Whether you like us, whether you don't like us, these are things you should do for your cloud. We talk about unique configuration and compliance management. This is your open S3 buckets. This is your overly permissive security groups. If you're not watching these, you're frankly asking for trouble. S3 buckets, especially guessable S3 buckets. If you've ever looked on the internet for open S3 buckets, you can see there's like tools on GitHub. You could download them, and what they'll do is they'll scan for open S3 buckets. And the way they do this is they take a company name and they put a -dev, or they put -prod, or maybe they'll try it in front, or -stage -QA. And I will guarantee you, if you take 30 seconds and try to do a curl to like pick any company and do a -dev after it, you'll find by the second or third company that S3 bucket exists. It doesn't mean it's open, but it means it exists. Now, if you scale that out to every company out there who has an AWS S3 account, you're going to find that some of those are open. And some of those will be open on purpose, but some of them will be open on accident. And not just being open, how open that bucket is really, really important. Because you can have read access, but there's also write access. And I've seen in some of our customers who've deployed, with permission, I looked through what data was visible, and one of them was a QA environment, and there was JSON files there, or sorry, JavaScript files. Now, this bucket was writable with JavaScript in what appeared to be a QA environment. What that means is a sufficiently advanced hacker, which is probably anyone who's going to be able to discover this, could take that JavaScript, modify it with whatever payload they want, upload it back to this QA environment, and pretty much have full control over whatever they did with that malicious data. So to make matters worse, it was also a guessable bucket. They used dot, so it was company name .dev, and it's really, really bad. And it took bringing up to them not once, but twice for them to really take it seriously. And this is because we're not used to these problems. These aren't problems you have in the data center. These aren't challenges that you had 20 years ago. These are challenges of the cloud that most of us didn't even realize were a thing. So it's something you need to take seriously. It's something that your security team needs powers to fix. You can't just say, team, you're responsible to monitor, but you can't close buckets because we don't want you to upset your engineers. So you kind of need powers. The next thing is your AWS resources. So misconfigurations are one thing. The other thing is you have a lot of AWS resources, and it's really, really hard to keep track of them. This is a little bit less of a security issue, but it still is. I have done consulting for a lot of companies where you'll go and look at their lab, and you find lots and lots of servers that are sitting there doing nothing in their lab. Amazon has a great tool called Trusted Advisor. You can click in here if you're a at least basic support customer, and you could look, and it will give you a kind of summary of what they feel is waste. And I've seen more than 3 customers who are wasting over $1,000, or sorry, more than $100,000 a month in underutilized resources. This is servers that were too big, that were receiving 0% CPU or no network traffic. And it exists. It exists. I will guarantee in at least half the people's environments, there's going to be a significant amount of waste. The bigger your company, the more likely it's going to be there. And the problem isn't just that it's underutilized. The problem is the person who spun it up, you don't know if they're still at the company. You don't know the access controls because it's generally in your lab environment. And your lab environment's where security kind of goes to die. You have like, I spun up a server as a consultant. I used it, and maybe I turned it off, maybe I didn't, I don't remember. But that's still going to exist until someone goes and audits it. And these are giant, giant security holes. These are things that we need to watch, we need to pay attention to. But it's really hard because you still need to empower your developer, and you still need to, run a business. And sometimes it's really hard to figure out who owns what and who did what. And especially with CloudTrail and how prolific it is, it's really hard to even go back and see who spun up this server or who did any of that. And then finally, there's servers and hosts. In the data center world, you didn't worry so much about this. You had your configuration management tools, you monitor everything at the firewall, maybe you got advanced with VMware and did some micro-segmentation. But for the most part, your east-west traffic was generally considered safe. But in the cloud, because it's so easy for someone to get in, and once they're in, they can kind of get anywhere, depending on if they came in from the AWS side or the workload side, you really do need to care about this. And you could see how important it's becoming because even some of the compliance standard like SOC and PCI are now requiring you to have things like file integrity, change monitoring. Host-based IDSs are starting to become more and more required. You're also seeing a lot of boards saying we need more visibility into what we're running. And this is because in the cloud, I can spin up something with a command, and with no visibility, like nobody knows about it, it's just in a black hole. And that's a security risk or a security threat. So this is sort of why Lacework was created. There was a couple reasons. The first is kind of the DevOps movement. So how many people use Docker or some sort of container? And of those, are these short-lived or long-lived? So this causes a large problem. When you have short-lived containers and you have a security incident and you're given an IP that says, this IP did something, it becomes a challenge to go back and figure out what that IP was associated with, right? And not only that, like going back and figuring out, was it my application? Was it someone on the box? Was it the root or was it the container? Like this all becomes very hard. And especially as things are living for a short amount of time, they're auto-scaling up and down. And so our founders, when they got together, they were talking about how do we solve this problem? How do we solve it at scale? And how do we make it something that's actually usable? And so I'm actually talking about the third thing first. And so what we did is we started analyzing your servers at the application and user level. So we're looking at what users are launching what processes. And then we're looking at the network level because we want to see what processes are talking to what processes. Then we're stitching that together and we're building behavior, much like they talked about before with guard duty. Indicators of compromise like bad IPs and bad DNSs are important, but they don't help you with the unknown unknowns. And so that's why behavior-based analytics are really becoming a thing, and that's why every security vendor out there is trying to do this. This is because it's the only way to detect most modern threats. It's trivial to change a file hash, and file hash is how most security has been done. All you have to do is vim a file, add a space, save it, recompile, new file hash, it's gonna fly under the radar. And so you have a whole security community who's trying really hard to catch up with all the known bad files and all the known bad IPs and all the known bad DNSs. But what happens is, one day it's a known bad IP, the next day your grandma has it. And so it's like a really important thing that you care more than just indicators of compromise, like known bads, and you actually care about what's actually happening in your environment, and you have a way to make sense of it. And not only do you have a way to make sense of it, but you have a way to make sense of what happened 2 weeks ago, because that's usually the lag between when something happens and either you get to it because we're all overwhelmed, or by the time you finally break it down to what exactly that problem was. In addition to that, we thought configuration and compliance is important. And so who here has heard of the CIS benchmark? The Center for Internet Security got together, they wrote a benchmark. And this is a sample of the minimum standards you should apply to your AWS account. This is things like don't let old IAM user accounts live forever. This is things like don't allow unrestricted access to port 22. You know, these are all things that if anyone ever worked with an old Active Directory and, you know, your old firewalls, like these are things you already did as a matter of course. And now they had to codify them because it's your one guy instead of 8 people on a team coming together and making decisions. And so we help you with that by automatically scanning them. And then what we do that's pretty cool is we take your CloudTrail logs. So you remember kind of looking through them. It's just structured JSON. It's really hard to make heads or tail of. We take all of this and we give you an easy to use and search interface for it. But then on top of that, we do behavior-based machine learning. So we see what your users are doing with it, what regions you're in, what your developers are doing with it, and we send you alerts when something interesting happens. And by interesting, it could mean maybe someone's using a new region, maybe someone created a new user, maybe you have a S3 bucket all of a sudden become open. And so this is the type of data we give you to like help when you're dealing with 20 or 30 accounts, we help you kind of filter out a lot of that noise and only give you things you care about. But since we're also not the only tool out there that's going to provide you with security insights, we give you the ability to do some research and see sort of what happened in your environment on any given day. So if you have a theory that, hey, this guy quit, he quit in an angry storm, I'm worried that maybe he did something in the account, you could look up all of that user's activity in AWS and see if he did anything suspicious. Or you could look at his IP address and see any servers he SSH'd into. You can see if you have good usernames, you can see his user. If you have bad usernames, you can see his IP address and user combo. And you can figure out anything he did on your servers. So it gives you visibility and understanding from almost every angle. So what I'm going to do now is I'm going to do a product demo. This will take about 20 minutes. But before I do this, I'd like to ask, does anybody have any questions? It doesn't have to be about Lacework. It could just be about general strategy for your AWS accounts. It could be about how I got certified, anything like that. I'm happy to answer any questions.
I might be asking this for everybody, but I definitely want to get that script for hacking.
Yeah, I have a whole set of scripts. I have a brute force script I'm happy to share. It will do an SSH brute force. It just uses an open source tool called Hydra. The other script I have is cryptocurrency mining. So by you deploying it, you are giving me a very small amount of money because I use my own wallet. I think I've made a solid $17 in the year I've been running it. So I'm pretty soon going to be rich. And then I also have some like known bad files that it's good for you to test your current environment, see if you have bad files and to see if they're alerted. It's just ICAR and it's, anyways, so I have those and they're available.
So yesterday, Hope, you mentioned that they went with you versus a few others.
Yeah.
So it'd be interesting to know why. Some interesting examples.
All right, so the question was, we had a presentation yesterday from one of our customers, Odie, and he had mentioned that he had used a competitor of ours before, but then they switched to Lacework. And the question was why and what differentiates us. So we have some things that are very similar. The CIS benchmark, that's similar across the board. There's a lot of companies who offer it. SecurityMonkey was an open source tool that offers it. So there's not a lot of differentiation there. But we start differentiating by what we're doing with CloudTrail. So because we're doing learning on your CloudTrail, and when I show you the demo, you'll see a little bit more about it. We are doing some advanced things that will send you data on, you know, without you having to write a rule, without you having to put a lot of effort into managing per account or across all of your accounts. It's just the deploy and it works for your CloudTrail. And what this is giving you is user login data. This is giving you what regions are being used, what's actually happening in your environment. We're securing like your Lambda functions based on what their roles are doing. So we give you that out of the box. It takes 5 minutes or less per AWS account. And then on our workload protection, that's really our true differentiator. Nobody does anything even close from a visibility standpoint. Like you can maybe find some other tools to find some of the data that we show you, but who here has done a security incident investigation before? A couple people. And when you're doing that, if you wanted to understand what process generated a connection to a DNS, how long do you think that would take? 10 minutes, 20 minutes? It usually takes a long time because it takes your system logs, it takes IP addresses, and you're trying to stitch all this data together. So you have to figure out what server made this DNS call, what IP it was. Then you have to log into that server and hope you have some sort of history of what happened on that server to understand. And with Lacework, it's literally, one, we'll send you an alert if it's the first time you've ever talked to that DNS. But the other thing is all that data is there for like a 2-second query. So you can look up and say, what servers in my environment have talked to this DNS over any time window over the last 90 or 180 days? So who's talked to pool.minexmr.net? You can answer that question in 4 seconds. And not only will we tell you what servers have talked to it, even if that server no longer exists, we'll also tell you the user associated and whether that was done via, say, a script or someone SSHing into that server.
Do you keep your separate logs for that, or does that still keep that?
We do it with our agent. That's how it collects that data. So it's kind of like a combination of visibility and because we're 100% machine learning based and we're doing behavior, when you deploy, you don't have to sit there and spend a month writing rules to codify your environment. And you don't have to pay someone full time to write and maintain rules and make sure that their rules aren't too noisy and suppress them. You just deploy it, it figures it out, it gives you visibility so you can go do investigations, and then from there you can tune. Any additional?
How did you get certified?
How what?
How did you get certified?
Sorry, I couldn't understand.
How did you get certified?
Oh, so I started out my certification. I went for the associate cert, and my first resource was A Cloud Guru. Now, this was before the website existed. It was on Udemy, and I took this training course, and I went through it, and then I did all the practice tests they offered. Then I went to take the test, and I failed. And I was really disappointed because the areas I failed in are things that I typically think I'm very great at. Troubleshooting, it's something I feel I'm great at. Obviously, if I failed, I'm not as good as I thought. And then the other was, it was around security. And so I was pretty upset about this. So then I went and looked, what other resources can I use? And I found Linux Academy. And Linux Academy, they had the guy who was doing the talks, I liked a little bit better. And I think it was just because I liked his cadence. I liked how he talked about things and how he described things. And this was early. This was 3.5 years ago. So it was early in the AWS certification thing. And both of them have come very far now. And you could use either one and get there. But what I learned is you need to take the videos seriously. But it's not that much work. It's about 20 hours of watching videos. Then you've got 5 hours or 10 hours of studying. And then once you're done with that, there's some tools out there that make it really easy. Like there's a tool called WizLab, and they give you kind of like great practice tests. But even without that, once you've done the videos and you've done the practice tests, you should be good. They're better now than they were. And so this is, at my consulting job, this was a requirement. Once we hired you, we needed you to get certified. So this is where I found out about WizLab, and everyone who's used it and used WizLab has passed on their first test, their first time. And then the Pro Cert, I did the same thing. I did all Linux Academy, and I took the practice test, and I went through and I copied down the practice test, which maybe I shouldn't have done, but I did anyways. And for every question that was asked, I went through and manually studied and made sure I knew the right answer. And I did this twice, and then I did it a third time. And the reason I kept doing it was because I kept failing the practice test. I was really upset about this. Previous to failing the first exam, I had never failed an exam in my life. And at some point, I just got overwhelmed, and I was like, I'm just gonna go take the real test. I took the real test, and I got, every section was either 90s, high 90s or 100%. So something about that practice test just didn't work for me. But it worked out when I got the real test. But anyways, the guidance I would give is I prefer Linux Academy because there's a lot of ancillary learning that you can do there. Like, let's say you're not necessarily strong in Linux. Linux Academy has great courses on that. Let's say you want to go for any of the specialties. It's a 1-month subscription that gives you a lot of access to training. If you think you're only going to get 1 or 2 certifications, A Cloud Guru is great because you buy a course, you own it forever. You can't really go wrong with either one, but I would recommend Wiz Labs. It's WHIZ Labs, I think, to do your final studying before the exam. It's worth it. It's definitely worth it. Other than that, it's just making sure you put in time to pay attention. What I started doing is I had a long commute, so I would just listen to the talks while I was driving, and it worked out pretty well for me. So
How do you spell the Wiz Lab?
I think it's WHIZ Labs. So if you Google Wiz Lab, it'll probably be the first one that comes up. Sure.
The other person.
Oh, okay.
There we go.
Perfect. You had a question? Yeah, sorry. Is it WHIZ Labs?
Labs.
Okay, perfect. So Labs with an S.
Do we have any comments about the recent cybersecurity attack like side channel attack? I mean, those maybe not related to if you manage some hosting service, but if you actually manage hardware,
Mm-hmm.
you're being attacked directly to the computer architecture itself. So is it something like brought into your work or?
So the question was like, this is like the hardware attacks, like the Intel vulnerabilities and things like that you're asking about. If that's pertinent, how do you protect against that? This is something where being on Amazon or one of the major cloud providers give you a decent level of security outside of what you could get in your own data center. Because like when the first one came out, I can't recall what it was called, Spectre. When Spectre came out, Amazon, Google, and Azure all were patched before it became publicly known. It was a big impact because it was costing like 20% CPU like utilization, and Intel stock isn't as good, and AMD stock is significantly better since then, like to the tune of double. This is because like the major companies, they have access to this information, and you know, it really affects Amazon more than it would affect you, because if you have your own data center, right, like somebody has to gain access to your VMs in your data center. So that means that one of your endpoints, right, like you either have a vulnerability or something like that. So if you're pretty consistent with security, it's a little harder. But if you're in the cloud and you go in, you get to that hypervisor, and that's a pretty large blast radius because it's shared resources. So this is why companies like Amazon work really hard to understand and be a part of the security community. This is why Amazon has more security professionals on their team than all of us combined, because they need it, because they are the target. So it's something that we could help with in very specific ways, because we're doing behavior-based learning on your servers. So new applications that show up in your environment, we're just gonna tell you about. So if somehow you're hacked with a CVE or something, we'll see behavior on the user, like your Redis user. I hate to keep going back to that example, doing
This
something
might be
interesting.
like more pertinent. Let's say I have some co-location provider where I'm hosting my machines.
Mm-hmm.
So in that scenario, do you think I should have a separate kind of protocol, because those machines are residing in someone else? I mean, even though we purchase the rack space,
Yeah.
but it is residing in someone else's facility. So what kind of security measure you would recommend?
So the question was, hey, I'm not using AWS, I'm using Rackspace. So we're using shared servers there. What kind of security is recommended there? Thankfully, Rackspace is large, so they're going to get their patches first. But there is a certain level of risk associated with using a vendor like Rackspace. So if you have managed services with them, it should help, because the moment a critical vulnerability comes out, they should be patching your hardware. For 0 days, there's really not much you can do other than something like us, where it's behavioral analytics, where you know, seeing bad behavior on your server is something that you want to watch and pay attention to, so you can immediately shut down access and remediate.
Do you recommend using
I'm not sure what IPMI is.
I mean, out-of-band protocol, like.
I think it really comes down to your risk. It's somewhere like Rackspace. It's really hard to dictate a lot of these things. So, like, honestly, your best bet is to keep yourself patched, have visibility, you know, have a set of rules, and make sure you have a good pro serve team monitoring your events. I mean, that's really the best we can do, because at the end of the day, we know what we know today. We know about known vulnerabilities, CVEs, things like that. And you could protect against those by having good policies in place. And the unknown part is what you really can't protect against. So that's why everyone's moving to behavior. So there's just, it's not great, but you have to protect yourself. And when you're in somewhere like Rackspace, you do worry about your peers. But the other part about being in Rackspace is they take security very seriously. So it's one of those things where you have to trust but verify with them, ask them what their policies are, just to ensure that it meets your needs. I mean, I would really consider Amazon too. Honestly, Amazon is really good about this, and if you're really, really worried, you can get dedicated machines at a click of a button. So it's not shared hardware, but it is very expensive, so you gotta be careful with that. But it's also a very small attack vector, and it'd be hard for them to get in and find you. So there is risk associated, but it's smaller than some other things. Any more questions?
Yeah, so what's the difference between Lacework CloudTrail with Amazon GuardDuty? Because you have been listening about GuardDuty all day, and it seems a little bit like similar.
So that's a great question. The question was, what's the difference between using Lacework's CloudTrail monitoring and GuardDuty? So remember today there was a lab using GuardDuty and SageMaker so that you got meaningful alerts. Think of Lacework as a much more powerful version of SageMaker. I mean, we have written the rules that they provided for SageMaker, and we have written a lot more things that are different and unique to us. So we're not more powerful as a platform for you, but from an ML algorithm and advancement perspective, we're much more powerful than what you used. So at the outset, what makes us the same is we're monitoring for bad IPs. We're monitoring for new location logins. But what makes us different is we're looking at what your roles are doing on a daily basis. So let's say you have a Lambda job deployed. It's only going to access the same one or two services because that's what Lambda does, right? It's a highly programmatic thing. Well, Lambda is a small attack surface, but if somebody hijacked your Lambda, right, there's two things they're going to do. One's Bitcoin mining, and you have to worry about that, but that's a small cost impact comparatively. And the other thing is they're going to hijack that role to try and do nefarious things in your environment. So the moment your Lambda that only is ever collecting data from Kinesis and pushing it into S3, the moment it tries to access IAM, we're going to send you an alert with the data about the role that did it and what happened. So you can go through, investigate, and figure out if this is something you need to remediate, or maybe your developers made a change. And if your developer has made a change, there would have been a paper trail of that too. Well, a log trail.
Okay. I think you just mentioned that, not now, but like earlier, you mentioned that Lacework also give the ability to have like overall view across regionals, right?
Yeah.
And also, I think they also mentioned, I think AWS is just under like regional base.
So that's another difference. The statement was, I mentioned earlier that Lacework is an overall view of your AWS account, while as GuardDuty is regional based. That is something that, with GuardDuty, it is a one check box to turn on, but it's per region. So with Lacework, you deploy it, we look at all your CloudTrail, and we figure out everything that all your systems are doing regardless of region. And so we track that, and we understand that, and we'll do cross-region learning there. So that is one of the other differences. Any more questions?
Is it a unified console of all your accounts?
Yeah, it's all one account in Lacework. All your sub accounts show up there, and we have a consolidated dashboard view. So let's say you have 10 AWS accounts, you can see all 10 at once and understand kind of the averages of it and see your change over time. And then we have an individual account view where you could look at, here's my OpenS3 buckets. Here's my old account credentials. And so, you know, there will be open S3 buckets that should be open, so we also allow you to suppress them too. All right, last call for questions. All right, demo time. So to start out, at Lacework, we basically generate a vanity URL for you. This is your company name or whatever you'd like to call it, .lacework.net. And this is your dashboard and your console. This is where all of your data is going to reside. We can make one account, we can make 5 accounts, however you'd like to split up your data, we can set that up for you. This is our demo environment. There's lots of bad things going on in our demo environment because otherwise it's going to be a very boring presentation. But to kind of summarize what we're doing, this is kind of a high-level sort of executive dashboard. At Lacework, we're processing a lot of data. This is our environment, but we're processing over 1 terabyte a day of data from some of our customers. This is data that includes CloudTrail logs. This includes compliance checks. This includes file integrity and change monitoring. So if anyone has SOC 2 or PCI, it's a requirement. You probably have something that's doing that today. This is all network connections, every inbound connection, every outbound connection. And then the other thing is all the processes running in your environment. So we're looking at all of this data. And what we're doing with this data is we're turning it into entity behaviors. And a behavior is process Redis-server run by user Redis, received a connection from this IP or from an external IP or an internal IP. Or one better, process Redis received a connection from process Apache, which is how you would expect your environment to work. And understanding what processes are communicating is really important. And this works for processes, this works for containers, this works for Kubernetes. And when something happens that's new or different to your environment, we're going to send you an alert. We also send you an alert if any known bad IP is being communicated with, or if any known bad DNS is communicated with. Additionally, we're doing a 256 SHA of all of your processes that are launched and anything in those directories that we're scanning for a FIM. And if any of those are known bad files, we're going to let you know. The idea here is this is the known bads. This is the things that you should always be checking for. And so when you deploy it, we'll let you know that. This is how you detect the problems that were discovered yesterday. The next thing we do is kind of those compliance reports. So kind of working through it. This is kind of table stakes for securing your AWS account. There are many ways to do it. This is ours. What we're doing is we're scanning your AWS account for the CIS best practices. So this is starting with identity and access management. This is CIS. The one I like to talk about the most is this one right here. You can see this little arrow lets you drop down and see which users are failing. So you can see these 3 accounts are accounts that have not been used for 90 or more days. You can see the one with Rakesh, there's even an access key that hasn't been used for 90 or more days. This is something where roughly 1/3 of all IAM accounts I've seen are failing this check. In your environment, I would bet across all your accounts, you're going to see about 1/3 of them are failing. Some will be better, some will be worse. The problem isn't that some are failing the check. The problem is I've also found, and I do a low-tech search, I take like that A. Westbecker name and I type it into LinkedIn with the company name I'm looking at. And a lot of these accounts are for people who are no longer at the company. And that's because IAM is the place where hidden accounts just live. It's like a graveyard of them. Because you either have your old AWS guru who came in and set everything up, or you had that consultant who came in, but they left the company, or maybe you moved to Okta or some sort of SSO, and you never got around to closing those holes or auditing it or fixing it. Plus, some companies have hundreds or thousands of IAM accounts, and how do you manage and maintain all of that? So that's why there's tools like this. But we do also know that maybe you have a break glass account. So we'll let you checkbox and click save, and that will suppress it. So the next time you run this report, it will show up as still violating, but it's not going to show up as failed. This is important because if you have accounts that are on purpose there, you still want to track them. More importantly, we do this for S3. So these aren't CIS checks. These are Lacework specific checks. By the way, all your accounts are here, and it's searchable. So when you have a lot, you could quickly get to what you want. We run this report daily or hourly. We do track all the changes in your environment outside of this. That's what our cloud trail is for. So even though you get a compliance report once a day, you have a list of all the changes that happen in your environment that's happening all the time. We also can regroup them for PCI or SOC 2. So if you're beholden to either of these standards, or maybe you're targeting them in the near future, this makes it really easy to collect that data. And like I was talking about, with S3 buckets, it's not only important to know if they're open, because read access is one thing. It's really important to know how they're open. You want to make sure if you have write access open, you need to make sure it's there. But what I've seen that's like even more scary is when people open up this check 4, which is granting the public the, sounds like I don't know, granting the public the ability to change who has access. Now this is like a bad deal, because people could come in, do whatever they want with their data, then they could lock out everyone but your root account from it. So things you don't want to have happen. And with Amazon, they've hugely improved their reporting of this. When you log in, it now shows you have public buckets. This is great, but they're not getting to the granularity, and they're doing it one account at a time. So it's still a challenge when you're trying to manage it for an enterprise. So you looking to a solution like this will really help you understand what's going on. We also have a lot of other checks. We have a bunch of custom Lacework checks built in too. We could go over them, but I think you guys get the picture. Now to kind of talk about that dashboard, this is how you see all of your accounts at once. You can see a quick view of how your accounts are trending. This is good because that's generally how security boards manage things. They want to see your compliance over time. So you can see here, this is a breakdown. It looks like logging is probably not doing too good in our account. S3, there's 1,000 S3 resources monitored, and almost a third of them are failing. So wouldn't be good if this was you guys. This is great for me because it makes a good demo. And again, you can filter to your individual accounts. So the next thing, this is that cloud trail I'm going to show you now. This is what I was talking about earlier. Now remember, I'm kind of showing you the eye candy part. I want you to remember that these are alerts that we're sending, so you don't have to look at this. You can just look at the alerts and make the judgments for yourself. And I'll get into some of the details of those alerts in a minute. But in essence, this is how our machine learning algorithm works. A lot of times when people think of ML, something like guard duty, you're not necessarily sure how they're doing detections. With Lacework, it's very easy to see. So this is quickly filterable. For every API call, and for CloudTrail, an API call is you logging into Lacework and clicking around, or your developer talking to AWS via their SDK, we track it, and we do basically this with it. So from left to right, you've got the account the API call came from, you've got the IP it came from, you've got whether it was an API call or console login, you have which is the person, principal, Amazon S3 service, who it was that was doing it. You have the target region, this is where the call went to. You have which API or service was used, and then you have what it did. And let's say it was an assumed role. You have any additional information like the role it assumed. So what you're seeing is a summary of everything that happened But you can see here, this was between 3 and 4 p.m. It looks like today. I'm pretty sure it's today. I guess it shows up here at the top. And we take this data and we aggregate it across your entire environment. And we compare this hour, so this was 3 and 4, we compare it to 2 and 3, and then all the way down. And what we're doing here is we have a visual baseline, and this is an equivalent of every rule we've just written for this hour. And we compare it to the previous hour and say, have we seen this before? If we've seen it before, we're not going to alert you. If we've never seen it before, we are going to alert you. Or if maybe we've seen it before, but now it has a bad IP as one of the logins, we're going to alert you. And the idea here is it takes 0 input from your team on your AWS accounts to have a very in-depth understanding of what's happening in your environment. And then on top of that, you then have empowered your team to go and do research if for some reason they have security information from somewhere else. Maybe there's some interesting Okta logs and they're like, now we have to go and look and see what happened. This also lets you see both in a visual manner, or you can operate filters. So like I can look at this Jenkins user and I want to see everything this Jenkins user did. So I just clicked here and it adds a filter at the top. And now the whole page is just going to show things that this Jenkins user did. And it's the log. It looks like he's describing tags quite a bit. Probably not that interesting, but this is how automation works. And that way you can go back and I can look, okay, I know that right now it's not bad, but maybe in January it wasn't so good. So you can either see all the activity between January and March, or you could go to whatever time window you want. Any questions so far? Sure.
This is great. What if you see an actionable alert come up? Is it something that you can automate with scripts?
So the question was, what happens if you see an actionable alert come up? How do you remediate it? Now, this is a very common question. I hear it all the time. At Lacework, we haven't stepped into the automatic remediation. We have developed some tools to give you to empower you to solve this for yourself. But this is kind of a directed decision by us because we found that almost no customer actually wants us to make changes in their environment. Everyone loves the idea of it. And for very specific setups, they think, okay, maybe you can close an S3 bucket for me. But if you're going to allow us to do something in that small of a scale, there's better ways to do it than anyone who's using CloudTrail. And Amazon provides these tools. There's some really great open source things out there that will help you do this. And it's something we'd be happy to partner with you to help you get there. But it's also something that your cloud security vendor probably shouldn't be making changes to your production environment. Now, I know some people have different opinions, but that's how I feel.
Does it allow you to do API calls to Amazon's APIs?
Yeah, so what we do is, here's an example of an event that happened. This is not all that interesting. It's a customer access key. But you can see here, here's our events. And these come out, we push these out to various tools. So let's say you have a Splunk. By the way, you save money by using us because you don't have to feed your CloudTrail logs to Splunk. You just feed our events to Splunk. So instead of spending 10 million lines of CloudTrail a day, you're sending 25 JSON messages. And then you leave your CloudTrail in S3 because obviously you'll want to copy somewhere, but it saves you all the analytics churn on it. But the idea is we send our event feed to whatever tool that your security team uses to monitor and respond to things. And then you would pivot in, you'd either, if it's like an open S3 bucket, you can say, when this specific event comes in, automatically remediate. And there's Lambda scripts that we offer that you could tie the two together.
That's what I'm talking about.
Yeah, so we can get there. Like I said, there are some different approaches to that involve some different tools Amazon offers that you could do in real time. We're limited, like you heard earlier today, CloudTrail is written every 5 to 15 minutes. So it's never going to be real time there. But the other thing is, like, once you receive an alert, this is where your SOC team can look at it and they could put together responses pretty quickly that way.
Once we get any anomaly, do we also provide investigation service?
Yeah, so let's talk through that a little bit. Let's see. So here's an interesting one. This is something that would worry me as a security professional. So I found an event and I clicked on it. And when it loads, I'll read through what it is. So this is CloudTrail change. So the event came in, somebody changed CloudTrail. And this says, for this account and one more, there were 2 CloudTrail changes. So we're trying to summarize in group events here. The idea is, if you have an automation job that does 35 things that are new or trigger an alert, you don't need 35 alerts. You need one alert with enough data to do the research all together. And so that's what we offer here. And then you could see the what, and you could see someone use the CloudTrail API and the name. And you could go through and you could see they named one Act 2 and they named one Consolidated, and you could see start logging. Now, I know what this is because I was working on a Saturday trying to get some interesting CloudTrail stuff done. I was trying to deploy kind of like a unique IAM role set up with CloudTrail, and this was me. But you can see where, so you can see the IP address that they logged in from, and then you can see down here the evidence. This is kind of the what happened. This specific instance is a service who generated it, so it was Amazon. But when you go down and see username CP, that's me. So you can track that CP called the API call. You can see the IP address I came from. So you can go back and say, hey, Chris, what are you doing messing with CloudTrail? Like, that's the one thing you maybe shouldn't be messing with. And I can respond, it wasn't me. And then you're worried. Or I could say, hey, I'm working on a project. It should be okay. And that's kind of the difference here. Like, that attribution to all the way down to who did it is really helpful, because otherwise you're sending something to your team and you have to wait for like them to look at it and decide if it was them, and maybe they forgot because they were just clicking through. And so this is no CP, user CP, it's an IAM role did it. This also happens for assumed roles. So if you were in one account and assumed the role into another AWS account, we would show you the source user and the destination user.
Do you have any recommendation service also how to fix the problem?
Not really. The question was, do we have any recommendation like services for how to fix the problem? This is something we've been talking about doing. The problem is we can do it for compliance because compliance events are very specific. You have an open S3 bucket, you have that. This is something that nobody wrote a rule for. This is just our system observing that I went in and modified CloudTrail, and this is something that I don't normally do, or that user doesn't normally do. And so the flip side of that is, if you have a service that's always modifying CloudTrail, I don't know why you do that, but I'm sure someone smarter than me could figure out a reason to. Like, you don't want an alert every day for that. So that's what we're doing here. We're trying to limit the noise that happens by your automation or by the things that your teams are doing, by your normal work function. And we're trying to only bubble up the things that are worth investigating.
What about if the company using the external like IDM to manage user, can you guys offer the tool to extend the coverage and make sure the integration you guys do the analysis or machine learning?
Yeah, so the question was, if someone's using an external identity management service, how do we kind of do the analysis? So if you're using something external, you'll see a login. The login type's a little bit different. It's usually like an assumed role or a SAML function or something like that. And we'll track that. And the data for kind of the source user who's coming in still exists in that authentication payload, and that is tracked in CloudTrail. So we still have it, and we do the attribution to the source user. This is very common. A lot of the ways teams manage multifunctional AWS accounts, you have like one master account. This is where all the IAM users or Okta users or Active Directory users are authenticated, and then they assume roles into other accounts. And so we'll track it and attribute it back to that source user, to the person that you'd want to do it on.
How long is the training time for your machine learning? Is it supervised or unsupervised?
So everything we do is unsupervised. We're training, remember I showed you the polygraph? Let me go back to it. So this is what we call the polygraph. This is what our ML is doing. This is how we're training it. We're comparing like this hour to this hour. And so like once they load, you'll see the difference. And it takes if you have a highly automated environment without a lot of manual interaction, it takes somewhere between 3 and 5 days for the alerts to go from high to low. But when I say high, we're talking tens of alerts a day, 20s of alerts a day, to less than 3 a day is low. Now, if you have a lot of manual activity in there, it can take up to 2 or 3 weeks. But the idea is the longer you have it deployed, the more we understand. And we do forget things on purpose. You don't want to have a permanent history. So, just because Bob used to do X, you don't want him to always be free to do X. But it takes a week, maybe 2 weeks for highly user authenticated environments, and a lot less time for our highly automated environments. Kind of think of it like a reverse Google PageRank, where like the most interconnectedness of things bubble to the top on Google, whilst for us it's the least connected. Things that happen infrequently, things that don't do a lot of communication. So everything I've shown you so far is the AWS side of things. I have talked about the workload security a couple times, but I'm kind of going to show you now. So the workload security this works on any Linux server anywhere. So if you have Linux, it's going to work. This is kind of a big nest. And if you look on the left, you can see where it says known bad IP and external IP. That's data coming into your system. Over here, you can see there's a bunch of DNS, and over there are IPs where DNS wasn't involved. That's data leaving your system. So that's sort of your north-south traffic. Everything there in the middle, that's your east-west traffic. If the Lacework agent's on it, we're showing the container or the process that actually did the communication. If the agent's not there, we'll just show the IP. And the idea here is you can have a container and it can live on 1 server or 2 servers, or however many servers it's scaling to, depending on how many of them there are. But you can have 2 things that have vastly different functions on the same server. So it's more important for you to understand what those processes are doing than what that server is doing. Because if you see incoming traffic on a server on port 80 and port 443, like that's expected. But if you start seeing random ports, you need to know what that server is doing. It's very important in a containerized world because containers can be scheduled anywhere, especially if we're talking Kubernetes. Does anyone here use Kubernetes? A couple of you. So you understand with pods, there's like an entire network overlay for it. IPs mean almost nothing at some point. And so that's sort of the point of our system, where instead of having IPs and ports, which we do have, we're converting it into processes and users. And again, it's filterable. So you can really go look and see what's happening. Here's that Redis server I've mentioned 1 trillion times. The idea here is you're not going to use this polygraph for a day-to-day investigation. But what you're going to use is the data that the polygraph drives. So what I'm showing you is a sample event. This is what you would expect from a tool like ours. Remember I mentioned the brute forcing earlier? This is a connection. This is a new internal connection. So there's some associated events I'll show you in the related timeline that would help you escalate the concern for this. This shows up as a medium because new internal connections happen often in your environment. But you can see here, there's an application called Hydra, and it was running on a server, and we give you the host name. And that Hydra was launched by user Ubuntu. then that application made a connection to SSH on a different server, which was running as user root. So the who's involved, and then the what's is where it kind of gets interesting. So we have, here's the application, external connections. These are all auto-answered questions. You can have the IPs of the servers involved, the names. And here we have the full command line for everything that happened on both sides. So because we're on all the nodes and we have that process level inspection, SSH command lines are not all that interesting. And we do special tracking for SSH because it is kind of like a privileged function. But we have that full command line there and available. So if you were a security person and you saw that first alert, you'd be like, well, I don't know what this application Hydra is. Maybe my developer was having fun. Then you scroll down and you see the command line. It's like username, password, 10 million passwords, IP address, SSH. Like, that should make you worried, right? And so that's sort of what that does. And then we have related events. So you could see that around this time, we also had a new user Ubuntu. We had a new user Ubuntu SSHing. And we have that new user Ubuntu logging in from a new location. So we saw earlier, Ubuntu launched a new process. Now we see that there's a new user and they've never logged in from this location. And then we can look at this polygraph. And this is something Lacework does that it's kind of like the picture is worth 1,000 words thing. You can see here that there was a user Ubuntu who SSH'd in from Cupertino. They were given a bash shell. This is very standard. If you've ever SSH'd in to a Linux server, you're given a bash shell. But what's important about what we have is we have the associated user. This was associated with the user Ubuntu. And then they performed the privilege escalation, and now it's associated with user root. So that right there is hard. We can track users across privilege escalation, and they can continue SSHing through your environment, and we'll still track it to that source. This is a differentiator for Lacework because most of the time, once you're root, you could delete all your tracks and all your trail because you're basically the super user. You have the power to do whatever you want. So we're able to see that he became root, then he launched this script that launched Hydra. Hydra generated 4 copies of itself and 292 SSH sessions. So the idea here is to get this information, you would have had to look through a lot of lines of code. I know because I scripted this out. It was something like thousands of lines by the time I was done because I had to download Hydra, I had to compile it, I had to download some things from S3, I had to generate the connections and everything. It's a decent amount of data, and I'm not trying to hide what it's doing. If you were a malicious user trying to hide it, it would be really hard to tell from any sort of logs what happened and how it happened. In addition to this, there's also some additional connection information, internal connection details. The way you would see something like this on another tool is you might have the destination and source IP, and you might have the fact that port 22 was used, and that would be how you know. And the way you would know is all of a sudden we went from 2 connections an hour to 200, and then it's up to you to look at these servers and figure it out. Here it's just 1 click. By the way, it's an automatic alert. Nobody had to think about it. Nobody had to write a rule. To kind of talk about another alert, and this is something that kind of makes Lacework unique, is because we do have that process to network connection piece. We can actually tell when something like this happens. So this was a new external IP address connected. So we have an external IP, which made an inbound connection to an application called Crypto. Crypto was listening on port 6379. Does anyone know what that port is? This is the default Redis port. So kind of building on this story, right? And it was running on this host. Now you can see here the user was Redis. And what makes this really interesting isn't the fact that it's using 97% CPU, which is probably interesting. It's not the fact that it's launching from temp/crypto. It's because outside of this connection, if you were to ping that server and connect to it on port 6379, you would have gotten the normal Redis client. you would have interacted with Redis the way you expect to interact with it. But what happened is this is a command and control hack where they're able to intercept specific connections and route it to a different application. So even though Redis is typically listening on this port, this came into this crypto app and it was able to update it. And once it was updated, it talked to a different DNS for its mining. And that's something that's pretty unique because if you had set written rules, you would have allowed this sort of connection. It's okay for whatever server pool to talk on this port to this server, and you would have never known that it was actually bad traffic. And so that's kind of the power of both behavior-based learning, and that's the power of having the visibility that Lacework provides. Being able to see what process generates or receives connections is really important. I truly believe this is how all vendors will be doing things in the next 5 years. Because understanding as you move into Kubernetes, what's actually happening is very important. There's a lot of other things we could kind of talk about, but I think I'm just going to summarize and then ask for questions. So we also track all your Linux users. So you can go back and see what any user's done on any day for the last 90 or 180 days. And this is good because you can see if they've generated, if they've deployed anything they've done. You can see their SSH sessions. You could see sort of the data transfer they've done. We also have a list of all your active containers. So any container that's active during whatever period of time will have that list. It's probably going to be in the hundreds or thousands for most of you. We also have your container registry because we're able to run as a privileged user on your servers. We're able to look at your container registry so we understand what's possible to be deployed. On top of that, we have Kubernetes constructs. So these are something some of you will be familiar with. With Kubernetes, it's kind of an orchestration tool that's designed to sort of give your developers a more friendly way to use containers. This is because a pod is a construct that your developers are used to working on, where they talk to other services within a pod on an IP, just like the way you would on a VM. Working with containers, it's slightly more difficult, so Kubernetes, part of the reason it's become adopted is because it's a little more intuitive for people who are used to programming before containers became a thing. So we have all your clusters visible and as filters, and all your namespaces visible. And again, we do the same thing. Here's a cluster view, here's like the pod communication view, and here's the blend. So not only are we protecting your containers and pods, we're also connecting the base OS that's hosting them. This is good because this is an attack vector, and you have some problems where you can have user ID escapes, where if you're not very good about what user IDs you're using on your containers and your base systems, you can have a situation where there's a conflict and you have a container that has the same UID as one of your base host UIDs, and your system doesn't know how to process this. So they can't figure out whether it was the container or the host that did whatever the command was. Or even if multiple containers are on the same system, you can't really figure it out. So that's one of the things we track and do. File integrity and change monitoring. Just to hit this again, we have changed files, new files, known bad files, and if your known bad files running anywhere in your environment, we'll also let you know. So it's pretty much a good high-level summary. Are there any questions?
Is it an on-prem app or cloud-based?
So this will work on any Linux server anywhere, but our dashboard is hosted in AWS and it's cloud-based. So your server, the agent has to be able to talk to api.lacework.net and S3. And then as long as that is possible, our agent will work.
How do you deploy the agent in a Kubernetes cluster? Is it a daemon set?
It's a daemon set. So kubectl create -f, you do your config map and then the deploy.
The early case when you had your server talking to the Redis,
Mm-hmm.
90% of the time, and you said the actual traffic is being redirected somewhere else.
Yeah.
How did Lacework figure it out? What was it done manually?
So automatic. So everything we do, there's no rules, there's no manual process anywhere. It's you literally deploy it, it builds the data, you log in, it shows it, we send you events. So the way we figure it out is on the host, we're looking at every network connection that's happening from it, right? So we're essentially doing a PCAP, so we're looking at the first 512 bytes. We're not doing deep packet inspection, and most of the time it should be encrypted anyway, so we wouldn't even try. So we're looking at the source port, source IP, destination port, destination IP, and protocol. But then we're also looking at all the processes that are live on your system. And we're stitching together what process is actually receiving a connection when it comes in, or what process generates it. So in that situation, most of the connections coming in, we see they're received by Redis-server, it's the name of the process. But in that instance, we saw that even though it was on the normal port, it was received by an application called Crypto that was running. And so we saw this, we knew it was weird, we sent an alert. You had a question?
Yeah. Can your product answer questions like I would ask OS Query?
Some questions, yes. We do have like a list of all installed packages, all binaries that are launched that weren't from an installed package. You have versions, and with our FIM, we'll be able to tell you like, you have 3 versions of Nginx running, even though they all say they're the same version. So we have a lot of what OS Query has, but it's not a one-to-one match. So depending on what you're using OS Query for, we could 100% replace it, or we could complement it. For example, Odie with Ernest yesterday, they use us and OS Query. Any additional?
Just to make sure Lacework in the second layers, right?
Mm-hmm.
Work on the first 3 layers.
Sorry, what?
Lacework, which layer is working in it?
So we run as an application or a process on your server, and we are looking at all the network connections, so we pretty much look at it all. But we're just sticking the network connection to the application.
So technically you're working the layer 3 networking, right?
Yeah. But it's at a server level, so it's a little bit confusing. Like a lot of times with layer 3, it's like your network traffic, like you're doing like a network PCAP with traps going to it. So because we're actually at the application layer too, we're playing in both. So application layer and network layer. And user layer too. So what is that, layer 8?
It's gonna be application.
Yeah, yeah. Any more questions? All right, so if you're interested, Lacework does a 30-day free trial. If you sign up today, we're giving out YubiKeys. I don't know if any of you have ever seen these. Google has something called, I think it's Titan, maybe it was Atlas, and the idea is it's a multi-factor key, and you press a button and it generates a code instead of you having to do your MFA thing. Since Google deployed this, they haven't had a single laptop compromised because of the security it provides. Pretty cool security tool. It's really great. I have my AWS accounts protected by it. There's one right there. They're pretty neat. I highly recommend getting them. They're called YubiKey, Y-U-B-I-K-E-Y. We have USB-C if you have a newer MacBook, and we have regular USB if you have anything else. So, thank you.